All right, so we're going to look at parent functions and transformations on this one. So we're specifically going to look at an absolute value, although this will actually, the same rules apply to other types of functions as well. So first, let's go ahead and take a look at what I'm talking about. So when translating a graph of an absolute value, or really you can apply this to function. We're just going to change some of the groupings when we're doing this. But let's go ahead and take a look at the absolute value first. So to graph y equals the absolute value of x minus a plus b. So we're going to shift. Here's the parent graph, which we see down here. This is actually the parent graph. This is what it would look like normally without any of this adding or subtracting. Well, we're shifting right a units, so I can see that here. And then we're going up b units, so I can see that here. And if you notice, and we'll keep going here just for a second. So here's x minus a and then minus b. So we're going right a units again because it's minus a, and we're going down b units because it's minus b. So if you notice, right should be positive, but this is negative. Well, it's because it's inside the grouping symbols. Whenever it's in the grouping symbols, it's kind of backwards. That's the easiest way to remember that. So just keep that in mind. Same thing when you're going down here. So now I have plus a, so we're going left a units, and then plus a, left a units. The second one, and it's going to be plus b, so that's up because it's not in any grouping symbol, it's outside. So plus does mean up, and minus does mean down. So just be careful about that idea. But what we want to pay attention to is the idea that we can see when a number is added or subtracted, inside the absolute value or grouping symbols. Doesn't just have to be absolute value, but in this case we're looking specifically at absolute value. Then the graph is translated horizontally, meaning we're going to go right or left. So notice the positive is left and the negative is right, just like I talked about, and this is because of those grouping symbols. Also, if a number is added or subtracted outside of the absolute value, like this b, then the graph is translated vertically, meaning up or down. So we do notice in this one that positive is up and negative is down, which is correct because it's not grouped in anything. So the symbol we see, the operation positive or negative, does respond the way we kind of intuitively think it should. So on this one, they just want us to translate this graph and move it. So first, let's focus on the horizontal translation. Oops, help if I turned that off. So we're going to go -4 units. We're going to scoot over 4 units, all right? And since it's -4, remember, that means even though negative usually means go left, gosh dang it, I turned the line tool on again, usually means go to the left, because it's inside the grouping symbols, we're actually going to go to the right. So we're going to go to the right here, 4 units. So I'm on 0 and I'm going to go 4. And then we want to do the same thing, and we can see it goes up 1 over 1, up 1 over 1. So it's got a very basic slope on it. So like this, boom, boom. This isn't the final one, I'm just showing you the first translation. 1 over 1, like that. Okay, so here's our first translation, and now we're going to do the second translation because there's a -3 on the end. So that means I need to bring it down 3 units. So let's turn this back on. So I'm going to go 1, 2, 3. So I'm going to start here, and it's the same slope. The slope hasn't changed at all. That's correct. And then like that. So we're not actually going to graph both of these. I'm just showing you. The red was moving it horizontally to the right 4 units, and the blue is actually the final translation of I moved it right and down 3. Because we had 2 pieces there. So again, remember on ALEKS you're not going to be doing both necessarily. You're only going to be doing one. So you want to make sure you're paying attention and just look at the vertex. Move the vertex these number of units, so right 4, down 3, and then make sure you match that slope. You can also create a little table if you want so that you know which points to do, but if you know what the slope is, then you can always match it very easily using that idea. Alright, so that is you graphing a translation of a function from its parent function. Now, I did mention that this works the exact same way, even if you have other types of functions. So you may have functions that look more like y equals g of x, something like this. And then you can have y equals g of x plus 3, or you can have something subtracted in here like this. They would work exactly the same way. Those are grouping symbols, just like the absolute value signs are grouping symbols. So inside of the grouping symbols would be moving it either right or left. Remember, it's kind of opposite of what we think. Outside of the grouping symbols moves it up or down. So that it works the same way, even though it's a slightly different looking graph. And then the other one that I saw on there was y equals something like this. And I think this is one that we practiced in class. So with this one, this is actually the grouping symbols, right? So it's the square root that's grouping it. So because I'm subtracting 1 inside of that grouping symbol, I'm going to move to the right 1 unit because it's inside what's being grouped. And then I'm going to go down 3 because it's outside of what's being grouped. So it does in fact go down with the negative. So the grouping symbols can change, but the rules still apply. You just change these. You can change them to parentheses or to the square root sign. It's whatever symbol is used to group. It doesn't really matter. It's just being grouped. So, all right, that was translating a function using its parent function. So I hope that helped, and I will see you in the next video.